Hello, this is Brian Ryo with assignment number 7 for the physics class. Assignment number 7 basically covers ray casting and the coring of objects through that. I'll start off with assignment number 2 since that is the only assignment I fully completed. Assignment number 2 was to create a version of Cut the Rope. So I've created this class called Arch Rope where you give it an X position and a Y position. So in this case, half the width all the way at the top of the screen, as well as the number of segments. So you have 2 segments for the rope. So if I cut this segment, that segment collapses, and the pig dangles on the joint from here to the second segment all the way to the ceiling. But that's not really fun. So because of the way I've modified this, I've been able to test it out with an even higher amount of segments. So this is with 200 segments, which creates this super elastic bouncy rope. And the same thing can be done. I can cut a piece of the rope, and as you can see, the elastic comes back up. I can wait for it to come back up, cut the rope again, and the physics engine will handle the rest. But that's also a bit too much, so the 20 mark is the most realistic without going crazy with the number of segments. So as you can see, I cut the segment, it turns red, and I cut that joint. There's 2 anchor joints, one up here, one up there, and I'll briefly go into the code to demonstrate how that works. So for the Arch Rope class, we take the total number of nodes, we add 1 to that, and that extra quote-unquote node will be the addition of the pig. So we take that into consideration. But what we have is we have a wood block all the way at the position that is given by the user, and we move it a little bit further, in this case the width of the wood block above, so that way you don't see the wood block and you only see the 2 ropes hanging from the ceiling like in the game. And we leave that as a static body, and our anchor points for our ropes will hang from this wood block. The next thing that we do is we calculate the points along a half circle. So in this case, right here, negative pi along the half circle, and with each one of those points, we create a block in between the previous point and the next point, and that's how we create all our segments for our rope. And we ensure that we save a position for our pig right here, as I mentioned, the future pig. So once we reach the halfway mark, that's where our pig will be, and we save that point for the pig. We place our pig into that position, and the next part is linking the rope. So just going very quickly through this, we start with the rope. We link it first to the wall. That's the very first thing we do. And then, as I mentioned before, we iterate through our array of points, and in between both of them, we place a block of the correct distance and the angle, so that way it makes a nice curved half circle. Gravity also allows the pig to be pulled down, and the rope gets applied with some sort of tension. But we create each one of those wood blocks. We make sure that the type is dynamic. Again, we put a revolute joint, and then we use the rope joint to hook everything up and to make sure that everything stays together and doesn't just fully break apart and go crazy. Under the case where we have to connect the pig, instead of placing another block, we place our pig in the next position, and it's important that we use 2 joints. We use 1 joint from the left-hand side of the rope to the pig, and then from the pig to the right-hand side, and generate from the right-hand side all the way up to the additional anchor point. Again, this code just briefly goes through all of that stuff. There's probably a way to minimize all of this, but it's just a quick demo. The very last thing is to make sure that I believe this is the left-hand side of the rope, because we go from right to left for my array of points. So the left-hand side of the rope, the final segment, needs to have one additional revolute joint connected to the ceiling, and this ensures that both sides of the rope at both ends are connected to the ceiling and connected to the pig. Then we delete our array of points since that's no longer needed for us. But what we do keep is we keep our array of joints, and our array of joints are required for when we raycast. We have to make sure that we have held on to those points, so that way if a link is to be destroyed, we can cut the revolute joint and the rope joint. But we always have to make sure that we cut the rope joint first and then the revolute joint second. And this basically keeps track of if we're cutting from the left-hand side or the right-hand side, because if you are on the right-hand side, you don't have to account for the displacement of the pig, which is the +2, because it's that additional joint between the midpoint and the pig, and whether we take into account that offset that I mentioned for the pig. But in general, that's how we create this rope and we start cutting segments. And like I said, I haven't been able to remove dangling rope pieces, but I'm sure that wouldn't be too difficult. I have not worked on the first assignment, which is the Fruit Ninja game, but it would run almost identically to this one. The only thing that I can imagine would be different is that we would have a structure on the ground, or we would have a factory that generates different types of birds and pigs, and we would just apply an impulse force, or an impulse going vertically towards the screen. And while on the screen, we do the same test with our raycast, cut the pig, and whether or not it was a pig or a bird, we would apply points to it. Like I said, I didn't get around to that one because I spent more of my time on the rope, and I just ran out of time. But other than that, I think that covers everything for this week. Thank you very much. Goodbye.